Hello, I'm Professor Basu. I'm currently the lead principal investigator of this Translational Center on Biomaterials for Orthopedic and Dental Applications. So, this is a multi-institutional joint R&D project which is sponsored by Department of Biotechnology, Government of India. So, today I am going to show you an integrated manufacturing protocol as how to develop patient specific femoral head implant which will be used for total hip joint replacement applications. So, on the material aspect, that this particular ceramic femoral head is made of alumina which is being toughened with zirconium dioxide, zirconia, and the manufacturing protocol that I will show you within next 2 to 3 minutes essentially involves the uniaxial compaction followed by slow machining, followed by sintering, again machining, and then polishing. At Indian Institute of Science, Bangalore, we extensively do 3D microstructural analysis, which is currently quite unique, and this 3D microstructural analysis is being carried out using microcomputed tomography, as well as we do lot of cell level and animal cell level testing as well as animal testing. So, essentially what we do at Indian Institute of Science, we take these particle elevates, then we grow different cell types like muscle cells or human mesenchymal stem cells, as well as we inject into the mouse model and try to understand that whether these particles can cause toxicity in vivo. And after that we do lot of histopathological analysis as well as blood parameter analysis in Indian Institute of Science, and then finally we do surface roughness as well as the bar strength property measurements and so on. The making of this ceramic femoral head is not an easy task. In next few minutes I will show you stepwise how to make this particular femoral head. So, the first step in this femoral head fabrication is to design the mold, and this mold what you see here, it is a high strength steel mold. It has a particular cavity as you can see. So, this cavity what we call is that bottom half of that entire mold assembly, and this is the female part of the mold assembly. And you see this mold cavity here inside, this mold cavity is to be machined with extreme care to have the desired roughness, because this roughness will determine what would be the surface roughness of this external surface of this femoral head. So, the smoother the surface of this femoral head, better would be the clinical performance of this particular femoral head. I will show you this entire mold assembly is now will be placed between the two platens of the uniaxial compaction chamber, and then this pressure will be applied in along the z direction, and this pressure will be, the force will be, the compaction force will be the order of 200 kilonewton, and this force will be applied for 5 minutes, and then at the end of this compaction cycle I will show you that how the green compact would look like. Now, let us watch that how the compaction process is accomplished. What you see in Akbar's hands is this green compact of the femoral head, and you see it is the top part and this is the truncated part. Now, what we need to do now is to sinter them at a predefined temperature and time, and for that we will put this green compact of the femoral head on this particular alumina base plate, which will be covered with a alumina lid. Now, it will be placed in that particular furnace. So, this is an indigenous make furnace, and in this furnace we will set the temperature of 1600 degrees Celsius and time, and it will be fired for 6 hours. So, as I said before, that this is the typical sintered zirconia toughened alumina femoral head compact. Now, I will show you how to make this polishing, and which you will find it quite interesting. So, what you see he is holding, this is a rotatable spindle, and then it can rotate with a very in a 360 degree with a maximum speed up to 40,000 RPM. So that's a very large speed that it can rotate. So first what you see that in this rotatable spindle, that femoral ball head is to be firmly attached. Now once it will start rotating, then you have to take this diamond polishing cloth of different grit sizes. What you see here 600 grit size, what you see here 1500 grit size. And what you also see here, which are placed here, 25 micron diamond polishing agent, 15 micron, 6 micron, 3 micron, and this is 1 micron. He will show you very quickly that how it while carefully rotating this particular femoral head, I must emphasize here the surface roughness should be less than 1 micron according to Dr. Sundaresh, and that too for many orthopedic surgeons. They always mention that surface roughness of value somewhere between 0.7 micron or lower than 0.7 micron is clinically most relevant for use in the total hip joint replacement. Although I have shown you that this is a model system of zirconograph and alumina, what we believe is that similar integrated, this identical integrated manufacturing protocol can be adapted to fabricate ceramic femoral heads of other compositions.